if a die is thrown, what are the possible events? It has 6 outcomes. So that is, you may get 1, 2, 3, 4, 5, 6. If 2 events cannot occur simultaneously in a random experiment, then they are mutually exclusive events. Suppose if a random experiment has how many outcomes? N outcomes, that M of these outcomes may be favorable to an event A. Hello dear students, welcome to this session of Basic Mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important chapter, that is probability. So this very important chapter, in this chapter you may expect 6 marks. The weightage for this chapter is 6 marks. So you will get one 1 mark question and one 2 mark question and one 3 marks question. That's all. Now here in this chapter, so what is the weightage for this? 1 mark 1 question, 2 mark 1 question and 3 marks 1 question. Totally 6 marks from this chapter you may expect. Now today in this session I am going to discuss regarding the introduction. So introduction, then the definition for probability and different types of definitions and the important terms associated with this probability and the example illustration. So just in this session I am going to discuss regarding the definition of probability and the important terms which connected to this probability, important definitions as well as some examples. Right. Now move on to the first one. So in introduction, what is probability actually? Probability is a measure of uncertainty. That is, it is nothing but a measure of an uncertainty. So the measure of an uncertainty is termed as the probability. Now the study of probability helps us to figure out the likelihood of something happening. So it is nothing but the probability will help us to figure out what is going to happen. So that is, so the probability helps us to figure out the likelihood. So the figure out the likelihood of something happening. Now let us consider, for example, tossing a coin as an example. If you toss a coin, suppose if you toss a coin, consider an example of tossing a coin. If we toss a coin, what is the possibility we are going to get? Either head or a tail. So you may get head or a tail. So here similarly, if a die is rolled, suppose if a die is rolled or thrown, what is the possibility? You may get 1, 2, 3, 4, 5, 6. So 1 to 6, either 1, 2, 3, 4, 5, 6. Like this, right? So now this is an example for tossing a coin. Suppose if you toss a coin, what is the event we are going to get? Head or a tail. So you may get head or a tail, right? So this is an example for a probability. Now let us move on to here. In statistics, probability determines other outcomes. So the probability will determine the outcomes in the statistics. And it is very important to identify all the different outcomes that could occur. So it is important for us to determine all the possible outcomes that would occur. Identify all the different outcomes. So the different outcomes that can be possible will be identified using the probability. Now the probability of occurrence of an event can be expressed as a fraction or a decimal. The probability of the occurrence of an event can be expressed as a fraction or even as a decimal, right? Now let us know regarding probability scale. What is this probability scale refers to? What are the possible things? Unlikely, equally likely, likely and certain events. So that is impossible events, unlikely events, equally likely events, likely events and certain, uncertain events, that is certain events. So impossible, unlikely, equally likely, likely and certain events. So impossible events are 0 and 0, that is 0% is an impossible event. Similarly, certain events, that is nothing but 1 or 100%. Now unlikely is 1 by 4, that is 0.25 in terms of fractions. Or equally likely means 50%, that is 1 by 2, that is 0.5, nothing but 50%. And likely event is nothing but 3 by 4, that is 0.75, that is equal to 75%. That means here what are the possibilities? So in impossible, 0 and 0, 0 is an impossible event. Now, unlikely events means, unlikely means that is nothing but 1/4, that is 0.25 or 25%. Equally likely means 1 off, that is 1/2, 0.5, that's equal to 50%. And likely events means 3/4, that is 3/4 is 0.75, that's equal to 75%. And certain events is 1, that is 100%. So this is the simple probability scale. So 0.25, 0.5, 0.75 and 1, that is 25%, 50%, 75% and 100% for unlikely, equally likely, unlikely and certain events. Now move on to the definition. Definition and some important terms associated with this probability. What is the definition for probability? So random experiment. Random experiment means any experiment that results into 2 or more outcomes. Any experiment that results into 2 or more outcomes is nothing but a random experiment. Example, if you toss a coin, what is the possibility? So the events may be either head or tail, one head or tail. So that means, so if any experiment that results into 2 or more outcomes is an example, is a nothing but random experiment. So example for random experiment is tossing a coin. If you toss a coin, what is the event we are going to get? Either head or tail. It has 2 outcomes, that is head and tail, denoted as H and T. Now let us take one more example. So if a die is thrown, or rolling a dice, if a die is thrown, what are the possible events? It has 6 outcomes. So that is, you may get 1, 2, 3, 4, 5, 6. So 6 outcomes. So therefore here S is equal to the number of outcomes are 1, 2, 3, 4, 5 and 6. 6 outcomes. This is also an example for random experiment. Right. Now next, sample space. What is meant by a sample space? The set of all possible outcomes of a random experiment. The set of all possible outcomes. What are the possible outcomes? The number of outcomes. All possible outcomes of a random experiment is called a sample space. Say for example, tossing a coin. If you toss a coin, what is the sample space? If you toss a coin, you are going to get 2 events, either head or tail. So S is equal to H and T. This is a sample space. S is equal to H comma T. That is called the sample space. Another example, tossing 2 coins. If you toss 2 coins, what are the possibilities? You may get head and head, then head and tail, tail and head, tail and tail. So first 2 head, first head, then tail, next first tail, then head, next tail and tail. So these are 4 possibilities, 4 events. So therefore the sample space associated with tossing 2 coins is S is equal to HH, HT, TH and HH, that is equal to 4 events. Now let us take one more example. Suppose when a coin and die is tossed simultaneously. If a coin and a die is tossed simultaneously, then what is the sample space we are going to get? The sample space are nothing but 1 comma head, then 2 comma head, 3 comma head, then 4 comma head, 5 comma head and 6 comma head. Similarly, we will get 1 comma T, 2 comma T, that is 2 comma T, and 3 comma T, 4 comma T, 5 comma T and 6 comma T. So totally there are 12 events. So when a coin is tossed and a die is thrown, then the possible sample space is 6, 1H, 1, 2H, 3H, 4H, 5H, 6H. Similarly, 1 comma T, 2 comma T, 3 comma T, 4 comma T, 5 comma T and 6 comma T. This is also an example for a sample space. Now, move on to the next one. Let us consider one more example, that is when 2 dice are rolled simultaneously. So, in each die there are 6 numbers 1 to 6. 2 dice are rolled simultaneously. Suppose if 2 dice, so 1 die, let us consider this die contains 6 numbers like this. Let us consider 1, 2, 3, 4, 5 and 6. 1, 2, 3. Now, let us consider the numbers first die. In first die 1, 2, 3, 4, 5 and 6. Similarly, consider this is another die 1, 2, 3, 4, 5 and 6. 6, 5, 4, 3, 2. Now, when these two dice are rolled simultaneously, what is the sample space? Let us consider first 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Next, second event. What is the second event? 2. 2, 1, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. Similarly, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Similarly, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And the last one is 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So, these are the sample space. How many are there? So, 1, 2, 3, 4, 5, 6. 6 into 6. 6 into 6, that's equal to 36 events. 6 into 6 is equal to 36. So, number of events in the sample space is 36 when two dice are rolled simultaneously. Okay. Now, let us take one more example. Next, let us move on to the next definition, an event. What's an event? So, any subset of a sample space is called an event. The subset of a sample space is called an event. Any subset of the sample space, that is, the subset of a sample space is called an event. Now, let us consider, for example, in rolling a die, the experiment 1, that is S is equal to 1, 2, 3, 4, 5, 6, then E is equal to 2, 4, 6 is the event of getting an even number, then this E is the subset of S, because all the elements of E are included in the set S, therefore E is the subset of S. That means E is the subset of S, means E is an event. That means any subset of the sample space is called the event. So, the subset of the sample space is called an event. Let us consider an example. If a die is rolled, then what is the sample space we are going to get? 1, 2, 3, 4, 5, 6. Now, let us consider the even numbers 2, 4, 6. So, is the event of getting an even number. Similarly, let us consider one more event, F. F is equal to odd numbers 1, 3, and 5. So, this 1, 3, 5 is also the elements of the set S. That means F is the subset of the sample space. So, therefore, F is an event and here E is also an event. So, E and F are the subsets, therefore, F and E are called as the events. Now, move on to the next types of events. Null event, or it is also called, null means what? Nothing, impossible event, and it is denoted as psi. So, null event or impossible event, it is denoted as psi. An event which does not occur, the event does not occur is nothing but an impossible event, that is null event. Example, getting a number greater than 6 in the single throw of a die. So, in a die there are 6 numbers 1, 2, 3, 4, 5, 6. So, there is no 7, 8, 9. So, getting more than 7, getting greater than 6, that is 7, 8 is an impossible event. This is an example for an impossible event, that is a null event. Now, let us consider sure events. What is sure event? They are also called as certain events. Sure events, or it is also called as a certain events. An event which contains all the outcomes, that is equal to the sample space. An event which contains all the outcomes, that is nothing but the sample space itself. So, the sample space is nothing but the sure event. So, an event which occurs all the outcomes, that is nothing but equal to the sample space, is an sure event. Let us take an example. Getting a natural numbers less than 7 in a single throw of die. So, natural numbers. So, the natural numbers in a single throw of a die is 1, 2, 3, 4, 5, and 6. This is an example for a sure event, that is, so the event contains all the outcomes. So, what is the sample space of a die thrown? So, 1, 2, 3, 4 is the sample space. So, n is the natural numbers less than 7 in a single throw of a die is 1, 2, 3, 4, 5, 6. So, therefore, then is a subset of yes. That means it is an example for a sure event. Now, next, simple event, or it is also called as the elementary event. Simple event or elementary event. That means an event which has only one outcome. An event having only one outcome is called an elementary event, or it is also called as a simple event. Example, getting an even prime number in a single throw of a die. Even prime number. So, even prime number in the single throw of a die is an example for a simple event. Similarly, getting two heads when two coins are tossed. Getting two heads when two coins are tossed head and head is an example for a sample. That is called a simple event. That is nothing but which has only one outcome. Head and head will get only one time. So, similarly, getting two tiles T and T is also an example for the simple event when two coins are tossed. Now, move on to the next one, compound event. Compound event means an event which has more than one outcome. An event having more than one outcome is nothing but a compound event. So, tossing a coin, if you toss a coin, you will get head and head. If a coin is tossed two times, you will get four events, more than one event. So, that is an event which has more than one outcome is called a compound event. Now, next, union and intersection. So, union and intersection of two events. Suppose if A and B are any two events, if capital A and capital B are any two events, then the occurrence of A or B is nothing but union of two events denoted as A union B. That is, the occurrence of A or B. A union B means A or B. The occurrence of A or B is called as the union of two events. Similarly, the occurrence of both A and B is called as the intersection. So, the occurrence of both A intersection B is nothing but A and B. So, union means A or B is called the union. The occurrence of A union B is nothing but A or B. That is nothing but the occurrence of A or B is nothing but the union, and the intersection A intersection B is nothing but the occurrence of A and B. Both A and B is called the intersection. Very important concept. Now, complementary events. What are complementary events? Complementary events means, suppose if S is the sample space of a sample space and E be any event, let S is the sample space and E is an any event. That is, let S is the sample space and E is any event which is associated with the sample space, then the complement of E is the set of all elements which are not in E, denoted as E bar or E dash. Also not E, denoted as E dash, or we can also write E dash or E bar. E dash, the complement. Complement means the complement of E is the set of all elements which are not in E, So, E union E dash is the sample space and intersection is a null set. E union E dash, suppose if E is a set, if E is the set and the complement of E is E dash, E union E dash is nothing but the sample space, and the intersection E intersection E dash is a null set. Okay. Now, this is also an important concept. Now, next, exhaustive events. Exhaustive events means, now let us consider a sample space. Yes, let S is the sample space. Let us consider the events A1, A2, A3, etc. AN. Suppose if S is the sample space, then A1, A2, A3, etc. AN are the events associated with the sample space. The total number of experiment is called as the exhaustive event. Okay, the total number of experiment. Total number of experiment is called the exhaustive event. That is nothing but union of all. A1 union, A2 union, A3 union, etc. AN is called the sample space is equal to S. That is, let S is the sample space, then A1, A2, A3, etc. AN are the events associated with the sample space. Then the total number of an experiment is called as the exhaustive event. The total number of experiment. The total number of experiment is called the exhaustive events. That is nothing but A1 union A2, A3, etc. union AN. That is equal to S. Now, sample space. Now, move on to mutually exclusive event. They are called as the disjoint events. Disjoint events. So if two events cannot occur simultaneously in a random experiment, then they are called as mutually exclusive events. So they are also called as disjoint events. That is, if two events cannot occur simultaneously, in a random experiment, then they are mutually exclusive events. Mutually exclusive. So if the event cannot occur simultaneously, in a random experiment, then they are called as a mutually exclusive events. Now move on to the simple note. Let us know regarding some important concept based on the definitions. Suppose if A and B are mutually exclusive events, then A intersection B is a null set. If A intersection B is a null set, then they are a mutually exclusive events. And if P of A union B is equal to, then probability of A union B is equal to 0. And the probability of A union B is equal to probability of A plus probability of B. So if A and B are mutually exclusive events, then A intersection B is a null set, then the probability of A intersection B is 0, and probability of A union B is equal to probability of A plus probability of B. Okay, hope you followed. Now move on to the next. If A and B are not mutually exclusive, first one is mutually exclusive, here they are not mutually exclusive, then A intersection B is not equal to null set. And if A intersection B is not a null set, means probability of A intersection B is not equal to 0. Right, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. See the difference. If A and B are mutually exclusive, intersection is a null set, probability of a null set is 0, probability of A union B is probability of A plus probability of B. Suppose A and B are not mutually exclusive, then A intersection B is not equal to null set, that is not a null set. Then the probability of A intersection B is not equal to 0. Then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay. Move on to the next concept, independent events. What are independent events? Independent events means events are said to be independent if the occurrence of one does not depend upon the occurrence of other. The occurrence of one does not depend on the occurrence of the other. So if the occurrence of one event does not depend upon the occurrence of other event, such events are called as the independent. That means that does not depend on any other independent events. So example, tossing a coin. If you toss a coin, so you may get head or tail. So head or tail does not depend upon anyone. So you may get head or tail. That is an example for a independent event. So the occurrence of one does not depend on other. So getting head does not depend on tail. Getting tail does not depend on head. So therefore, tossing a coin is an example for a independent event. Now, two events A and B are said to be independent if and only if probability of A intersection B is equal to probability of A into probability of B. Very important. Two events A and B are said to be independent events if and only if probability of A intersection B is equal to probability of A into probability of B. In general, for n independent events, there are n independent events, then probability of A1 intersection A2 intersection A3 etc. intersection AN is equal to product, that is probability of A1 into probability of A2 into probability of A3 etc. into probability of AN. That is probability of A intersection B is equal to probability of A into probability for two independent events. That is, if two events are independent, that is the occurrence of one does not depend on the occurrence of other, then probability of A intersection B is probability of A into probability of B. Therefore, in general, if you take n number of events A1 intersection A2 etc. AN, then that is equal to probability of A1 into probability of A2 into etc. into probability of AN. Now, move on to the next one. Consider an example for this. Consider a fortune wheel which is divided into 7 sectors, Vib Goyal, each sector with 1 rainbow colors. 7 colors. Vidhyaashram. So 7 colors are there. Consider a fortune wheel which is divided into how many colors? 7 colors. So that is 1, 2, 3, 4, 5, 6 and 7 colors are there. So 1, 2, 3, 4, 5, 6 and 7 colors. 7 colors, that is rainbow colors. Now here experiment, spinning the fortune wheel. So if we spin the fortune wheel, what are the outcomes? So the outcomes may be getting any one of the 7 colors. Getting any one of the 7 colors. So the 7 colors are Vidhyaashram: violet, indigo, blue, green, yellow, orange and red. So the sample space is VIBGYOR. Right. That is experiment spinning the fortune wheel. If you spin the fortune wheel, what are the outcomes? Getting any one color of the 7, any one of the 7 colors, any one of the 7 colors. That is nothing but the sample space is VIBGYOR, 7 colors. Next, null set. Null set means getting brown color. Brown color is not there. See, violet, indigo, blue, green, yellow, orange and red. Brown is not there. So therefore getting a brown color is nothing but a null event. Now sure event, getting rainbow colors. Rainbow colors means all the 7 colors. Getting all the 7 colors is a sure event. Next, simple event. So next is simple event. Example for simple event is pointer landing on the yellow. Suppose if the pointer lands on the yellow is an example for a simple event. Compound event means getting 6-lettered color. 6-lettered color. Getting 6-lettered color, that is VYL. Getting 6-lettered colors, that is V, Y and L. That is a compound event. Now, we want to mutually exclusive event. So, what is mutually exclusive event? Means 4-letter color. 4-letter color. Then B, 5-letter color. So, independent event means occurrence of any one of the color out of 7 colors. The occurrence of any one of the color. Occurrence of any of the colors out of the 7 colors is nothing but an independent event. So, one does not depend upon the other color. So, mutually exclusive means A is equal to 4-letter color, 4-lettered color, and similarly B is an event 5-lettered color. Independent event means occurrence of any of the color out of the 7 colors. Right. Now, next, approaches to the study. Now let us approach us to the study of probability based on all the following definitions. There are 3 systematic approaches. What are that? First one is the classical approach, that is called mathematical approach, and the second approach is called frequency approach, that is called as a empirical approach, and the third one is axiomatic approach. So there are 3 types of approaches. There are 3 systems of approaches of probability: classical approach or mathematical definition, or frequency approach or empirical definition approach, or axiomatic approach or axiomatic definition. Now, let us move to the classical or mathematical approach. What is the classical definition for probability? Now, let us discuss regarding the definition of probability. What is the classical definition or mathematical definition? Let a random experiment have n possible outcomes. Suppose if a random experiment has how many outcomes? N outcomes. Let m of these outcomes may favorable to an event A. If m number of events are favorable to any event A, then the probability of A is given by P of A, denoted as probability of A. And what is this probability of A is given by number of favorable outcomes divided by total number of outcomes. The probability of A is equal to m by n. So, probability of number of outcome divided by the number of possible events is called the probability. That is, so suppose if let a random experiment have n possible outcomes, let m be the m of these outcomes may be favorable to any event, say A, then the definition for probability of the event A is P of A is equal to number of favorable outcomes divided by total number of outcomes. This is an example. So, for example, let us take tossing a coin. What is the sample space? Head and tail. Now, let us consider an event. What is an event? Getting an head is an event. Then, what is the probability of A? Probability of A is nothing but n of A divided by n of S. What is n of A? Here, number of events in A is 1. Number of events in S is 2. So, that's equal to 1 by 2 is the probability of getting a head. That's it. This is the mathematical or a classical definition of probability. Now, move on to the next one. So, points to be remembered here. Now, based on this definition, what are the important points? The points to remember, the range of probability is 0, 1, closed interval 0. So, in between range of a probability, the range of a probability is always 0, 1. That means probability of any event which always lies between 0 and 1. So, not greater than 1 and not less than 0 also. That is 0 less than or equal to probability of A less than or equal to 1 or 100%. The probability of A is 1 or 100%. That is nothing but 0 less than or equal to P of A less than or equal to 1. Then probability of A is equal to 1 means for sure event. If the events are sure, then the probability of that event P of A is equal to 1 or 100%. If P of A is equal to 0 means for impossible or null events. If the probability is 0 means then it is an impossible or null event. If the probability is equal to 1 or 100%, then it is a sure event. So, probability of A dash complement, A dash is equal to 1 minus probability of A. Probability of A dash is equal to 1 minus probability of A. That is for complementary events. For complementary events, probability of A dash is equal to 1 minus probability of A. That's it. Okay. So, these are few important points to be remembered while solving the problems. Okay. So, that's all regarding today's session. So, these are few definitions and the examples for probability and different terms. So, that's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you. Thank you very much.